On April 19th, 2026, on a road in Yizhuang in southern Beijing, a red humanoid robot named Lightning crossed a finish line. Time, 50 minutes and 26 seconds. The human world record for the half marathon is 57 minutes and 20 seconds. It is held by Jacob Kiplimo of Uganda, a professional athlete at the peak of human physical conditioning, who trained for years to achieve that performance. Lightning beat it by 6 minutes and 54 seconds, in its first competitive race of any kind. Built by a Chinese smartphone company, running on a course lined with people who had come to watch, most of them expecting the robots to fall over. Several of them did fall over. Lightning was not one of them. If you stopped there, the story would already be one of the more remarkable things to happen in robotics in recent memory. But stopping there would mean missing the part that actually tells you something. The number that should stop you is this. Last year, the winning robot in the same race took 2 hours and 40 minutes to complete the same course. 1 year, from 2 hours 40 minutes to 50 minutes, 26 seconds. That improvement in 12 months is the data point that explains what is actually happening in China's humanoid robot industry right now, and why the people who study this field for a living are scrambling to revise projections they published less than 12 months ago. Stay with me, because by the time we are done, you are going to understand not just what happened on April 19th, but what it means for the factories, the supply chains, the labor markets, and the competitive dynamics between China and the United States across the single technology category that most serious analysts now believe will reshape the global economy more fundamentally than AI, EVs, and batteries combined. Every number in this video is sourced, confirmed, and documented, including the ones that complicate the story. And if this channel's commitment to both the extraordinary and the honest is why you watch, subscribe right now, because this story goes deep. Let us start with what actually happened at that race, because the full picture is considerably more interesting than the headline. The 2026 Beijing E-Town Half Marathon took place across 2 categories running simultaneously. A standard human race and a dedicated humanoid robot half marathon on a separate lane. More than 100 humanoid robot teams entered the robot category, up from roughly 20 teams the previous year. That 5-fold increase in participation is itself a signal worth reading. In 2025, the inaugural race was something between a scientific demonstration and a controlled disaster. Only 6 of 21 competing robots finished the course at all. Many fell repeatedly. Several lost structural components during the race. The winning time of 2 hours and 40 minutes was slower than a brisk walk. Spectators who attended described watching robots spin out of control, tumble over, and require frequent intervention from the human handlers who walked alongside them. In 2026, the picture had changed enough to be genuinely difficult to reconcile with the 2025 footage. 1 year. Same course, same rules. Completely different machines. The specific engineering changes responsible for that improvement are documented, named, and technically precise, which is why this is not just a feel-good story about China's technological ambition. It is a case study in how a focused national manufacturing ecosystem, running many parallel teams on shared platforms with shared simulation infrastructure, resolves specific engineering bottlenecks faster than a smaller number of independent teams working in isolation. Approximately 40% of the entering teams ran their robots fully autonomously, using onboard sensors and navigation systems to manage the course without real-time human control inputs. Lightning, the winning robot, is 169 centimeters tall and was built by the Qitian Dasheng team, running under sponsorship from Honor, the Chinese smartphone maker. Its design team modeled its leg proportions on elite human runners with legs approximately 95 centimeters long. It uses what Honor's test development engineer Du Xiaodi described as a liquid cooling system largely developed in-house, adapted from thermal management technology the company already had from its smartphone manufacturing. At the average speed it maintained through the race, approximately 25 kilometers per hour, which is 5 miles per hour, it showed no visible signs of slowing down as it passed the finish line. It then crashed into a barricade. Its handlers caught it, set it upright. It was fine. This is where Scientific American's coverage becomes essential to include, because the most important journalism on this event was not the congratulatory kind. Rodney Brooks is an emeritus professor at the Massachusetts Institute of Technology. He co-founded iRobot, the company behind the Roomba. He now runs Robust, AI. He has been in robotics longer than most of the teams who competed on April 19th have been alive. His assessment of the race: it is just a stupid publicity stunt. That quote deserves the sentence all on its own. And then it deserves a full and fair explanation, because Brooks is not wrong to raise the concerns he raises, even though his conclusion undersells what actually happened. Scientific American's piece, published 3 days after the race, was precise about the limitations of what Lightning's performance actually demonstrated. The robots ran on a dedicated, rehearsed course, not a general environment. Support crews trailed behind every competing robot. 62% of the robots were still being remotely piloted during the race, rather than navigating autonomously. Lightning itself, despite crossing the finish line faster than any human ever has, crashed into a barricade immediately afterward, requiring handler intervention to remain upright. A robot that can sprint at 25 kilometers per hour but cannot stop reliably when the course ends is not yet a robot that can be deployed independently in environments it has not been specifically prepared for. Brooks's point is that running fast on a rehearsed straight course with a trailing support crew measures something real but does not measure the full range of capabilities required for humanoid robots to do what their commercial proponents claim they will do inside factories, warehouses, hospitals, and homes. That is all true, and it is consistent with something else that is also true. The same improvement from 2 hours 40 minutes to 50 minutes 26 seconds achieved in 12 months happened against all those same constraints. The course was also rehearsed last year. The support crews were also trailing last year. The environment was also controlled last year. What changed was the technology, and technology that improves by that margin in 12 months inside a controlled environment tends to keep improving when the environment gets harder, not to stop suddenly because the next challenge is more difficult. The context behind that improvement rate is the industrial story that the race was specifically designed to showcase, and the People's daily coverage of the event was unusually specific about what drove it. Teams competing in 2026 credited the performance gains to major improvements in 3 specific areas: material durability, system reliability, and joint heat resistance. The last of those, joint heat resistance, is the specific failure mode that stopped most 2025 robots before they could complete the course. Running a humanoid robot at sustained speed generates enormous thermal stress at the actuator joints. The 2025 robots overheated at sustained speeds, which forced them to slow down, stop, or malfunction. The 2026 robots had solved that problem well enough to maintain competitive pace for the full 21-kilometer distance. The motion control team behind Tiangong 3, Zero, one of the competing robots, disclosed that their training process involved tens of thousands of virtual robots logging a combined 27,300 hours of simulated running through over 100,000 algorithm iterations before the physical robot was put on the track. The specific statement from Xu Jiwan, head of motion control at the Beijing Innovation Center of Humanoid Robotics, is worth quoting directly. At near-professional human speeds, perception and decision-making windows shrink dramatically, requiring major upgrades in power, algorithms, and system responsiveness. That sentence, perception and decision-making windows shrink dramatically, is the most precise technical description available in public reporting of why running fast is fundamentally harder for a humanoid robot than running slow, and why beating the human record is a more significant engineering milestone than it might superficially appear. A robot walking slowly has relatively generous time to process sensor inputs, decide on foot placement, and execute joint corrections. At 25 kilometers per hour, the time between a foot making contact with the ground and the next foot needing to be placed is measured in milliseconds. The sensor pipeline, the prediction algorithm, the motor command, and the physical actuator response all have to complete their cycle in a window that shrinks in proportion to speed. The 2025 robots could not sustain that loop reliably. The 2026 robots could. That is not a trivial improvement. That is the specific engineering bottleneck that all humanoid locomotion research globally has been working to solve. The simulation training scale matters specifically because 27,300 hours of virtual running logged by tens of thousands of simulated robots is a data generation strategy that individual university research teams and small startups cannot replicate on their own compute budgets. It is the same data flywheel dynamic that gives KATL its battery advantage and BYD its autonomous driving advantage, more real and simulated operational experience accumulated faster, feeding back into better models and algorithms, which enable the next generation of hardware to perform at a higher level, generating more operational data in turn. The teams competing in the 2026 race were running on the product of that flywheel. The teams who will compete in the 2027 race will be running on its output, plus another 12 months of improvement cycles, across 100+ teams, simultaneously generating different algorithmic approaches on shared hardware platforms. People's Daily noted a detail in their coverage of the race that has not received enough attention elsewhere. Many teams use the same robot base model, yet their performance varied widely depending on software and system optimization. These secondary developers range from companies and research institutions to university teams and independent enthusiasts. The base model is like a blank shell, said Du Yuhan, a doctoral student from Huazhong University of Science and Technology. We bring it to life through our own ideas. That developer ecosystem dynamic, where a standardized hardware platform becomes the substrate for hundreds of independent software teams competing to optimize it, is the same dynamic that made Android dominant in smartphones and that made open source Linux dominant in servers. When a hardware platform becomes good enough and cheap enough that the interesting competition shifts entirely to the software layer, and hundreds of independent teams are simultaneously competing to write better software for the same physical system, the rate of capability improvement accelerates beyond what any single company's roadmap could achieve on its own. Now, let us talk about what this race sits inside, because the event was not a standalone performance. It was a showroom for an industry that is moving faster than almost any public projection from 2 years ago anticipated. And it is worth saying directly, before the numbers arrive, why this matters for anyone who is not a robotics engineer, a technology investor, or policy analyst. If humanoid robots cross the economic threshold, where their total cost of ownership over a working life is lower than the equivalent human labor, in the manufacturing, logistics, and industrial maintenance sectors at the scale that current projections suggest by 2028 to 2030, then the labor market assumptions built into most national economic plans, most pension system projections, and most workforce development strategies written in the last 5 years are wrong. Not slightly wrong, structurally wrong in a way that will require significant recalibration. The April 19th race is not a sporting event. It is a milestone in a capability curve that, if it continues at the rate it has demonstrated over the last 12 months, reaches commercial viability at scale within a window that is shorter than most government planning cycles. China's investment in robotics and embodied AI reached 73, 5 billion yuan, approximately 10, $8 billion US dollars in 2025 alone, according to a study by a government agency cited in Al Jazeera's coverage of the race. In the first quarter of 2026 alone, the humanoid robot sector completed 14 funding rounds, each exceeding 1 billion yuan, compared to only 6 such rounds across the entire previous year. Agibot, a Shanghai-based humanoid robot company founded in 2023, delivered its 1,000th unit in mid-2025. By March 30th, 2026, it had delivered its 10,000th. It crossed the 15,000 unit mark on June 28th, 2026, less than 3 months after the 10,000 unit milestone. The acceleration in manufacturing throughput is not gradual. It is the kind of curve that industrial analysts describe as crossing an inflection point, where the bottlenecks that previously constrained volume have been systematically removed and the constraint shifts from capability to demand. Unitree Robotics, the Hangzhou-based company that competes with Agibot for leadership in Chinese humanoid manufacturing, published financial disclosures as part of its Star Market IPO application that include a detail with significant implications. The bill of materials for its G1 humanoid robot stands at approximately $8,176, below $9,000, for a walking, lifting, carrying, assembling humanoid robot. For the first time in the history of commercial humanoid robots, that figure falls below the threshold, roughly $30 per hour, or approximately $62,000 annually, at which a humanoid robot's cost of ownership over a multi-year working life is economically competitive with hiring a human worker for the same tasks in high labor cost economies. A robot that costs less to own and operate than a human employee, and that can work around the clock without breaks, benefits, or turnover, has crossed the line from technology demonstration to economic proposition. This is not a projection. Unitree's own IPO prospectus shows 2025 revenue of 7 billion yuan and a net profit of 591 million yuan with gross margins of 13%, making it one of the few profitable embodied intelligence companies anywhere in the world at the moment. Unitree is targeting 20,000 humanoid units in 2026. Multiple analysts forecast the manufacturing cost falling toward $20,000 per complete robot unit by 2030, comparable to the price of a car. At that price, the question is not whether industries will buy them at scale. It is which industries will buy them first. The competitive context for these numbers is important to state clearly because it is not a story of China operating in a vacuum. Tesla's Optimus program is real. Elon Musk dismantled the Model S X production line, operational for 14 years, in a 120-day retrofit specifically to accommodate Optimus 3 manufacturing, with a designed annual capacity of 1 million units, targeting production beginning between late July and August of 2026. Figure AI, Agility Robotics, Boston Dynamics, and Apptronic have collectively raised billions of dollars and are deploying robots in real industrial settings. Boston Dynamics' Atlas has been performing physically impressive demonstrations for years. Agility's Digit robots are operating in Amazon warehouses. The American humanoid robotics field is not standing still. But the gap in volume is now measurable and significant. London-based technology research group Omdia ranked 3 Chinese companies, Agibot, Unitree, and Ubitech, as the only first-tier vendors globally for general-purpose embodied intelligent robot shipments. Chinese firms controlled approximately 90% of global humanoid robot installations in 2025, with Chinese firms installing approximately 276,000 industrial robots in that year, compared to approximately 35,000 in the United States and approximately 46,000 in Japan. The Forbes analysis of the humanoid robot investment landscape, published in April 2026, stated the competitive structure directly. China dominates volume. The United States dominates ambition and funding. The supply chain advantage in actuators, batteries, and assembly is structural and probably durable. That phrase, structural and probably durable, is where the story of the April 19th race connects most directly to the longer-term industrial competition. And it is the phrase that every American robotics company's strategy team should be reading carefully. Lightning ran fast because of a liquid cooling system adapted from smartphone manufacturing. That adaptation was possible because Honor, a smartphone manufacturer, had already built deep engineering expertise in thermal management for consumer electronics, expertise that had commercial value in a completely different context when a new market required it. This is the specific form of industrial advantage that accumulates over decades and manifests in unexpected places. A manufacturing ecosystem built for one product, generating technical capabilities that transfer cheaply and quickly to a different product that needs the same underlying engineering. China's electronics manufacturing base, its battery supply chains, its motor and actuator component industry, and its AI research output have been converging on humanoid robots for years through exactly this mechanism. The 5 international teams that participated in the 2026 Beijing race from countries other than China all chose to compete on Chinese-made base models. Not because Chinese robots are the only ones available, but because they are the ones available at competitive cost with sufficient documented performance for a team to build on. UBTech signed a service agreement with Airbus in early 2026, marking what the company describes as the first humanoid robot deployment in aviation manufacturing. UBTech's other confirmed industrial partnerships include Siemens, Texas Instruments, Audi FAW, BYD, and Foxconn. China's State Grid Corporation issued a 8 billion yuan, approximately $1 billion US, procurement order for 500 humanoid liveline working robots, 3,000 dual-arm robots, and 5,000 quadrupedal robot dogs. That is the largest single procurement order in the embodied intelligence sector to date. It is a government utility company buying robots for grid maintenance work at a scale and price point that 2 years ago did not exist for any robotic system that could perform the task. Here is the honest frame for understanding what Lightning's time of 5026 actually tells you and what it does not. It does not tell you that China has solved the general intelligence problem for humanoid robots. The robots at the April 19th race ran a specific, prepared, rehearsed course with support teams trailing them. The 62% that were not running autonomously were demonstrating speed and endurance, not general-purpose intelligence. Lightning crashed at the end. These are real limitations, and Rodney Brooks is professionally right to name them. A humanoid robot that runs at 25 kilometers per hour on a flat, rehearsed circuit cannot necessarily navigate a cluttered warehouse, a hospital ward, or an uneven factory floor without significant additional development work. The gap between running fast on a prepared course and operating reliably in an unstructured environment is the gap that has defined the frontier of humanoid robotics research for decades, and it has not been closed by a 50-minute half marathon. What it does tell you is that the rate of improvement in Chinese humanoid robot locomotion, endurance, autonomy, and thermal management went from a winning time of 2 hours 40 minutes to 50 minutes 26 seconds in exactly 12 months, and that the industrial ecosystem producing these robots is simultaneously crossing its first economic threshold, with bill of materials costs falling below human labor costs and scaling to production volumes that were described as aspirational targets just 2 years ago. Those two things together, extraordinary improvement rate and commercial manufacturing inflection, are what makes April 19th significant as a data point, even with all of Brooks's legitimate caveats fully accepted. A senior Chinese researcher who watched both the 2025 and 2026 races captured the emotional reality of the moment in a statement that Al Jazeera reported directly. For thousands of years, humans have been at the top on planet Earth. But now, look at robots. Just in terms of autonomous navigation, at least in this specific sport event, they're already starting to surpass us. On one hand, it does make you feel a little bit sad for humanity. That is not a boast. It is a candid reaction from someone who has spent their career building these machines and was not fully prepared for what they saw when they started to work. Subscribe right now if you want this channel to track exactly where the gap between prepared course performance and real-world deployment capability closes, and when and which companies on which side of the Pacific close it first. The World Humanoid Robot Games are scheduled for August 2026. Tesla Optimus 3 is entering production between late July and August. And the WEC World Artificial Intelligence Conference in July will include humanoid robot demonstrations that will set the next benchmark the industry is measured against. Every one of those events is a data point in the same story, and we will cover all of them. But before the closing question, there is one more piece of the April 19th story that nobody in the Western press picked up on, buried in the People's Daily coverage, and confirmed by Liang Liang, Deputy Secretary General of the Chinese Institute of Electronics. He said, nearly 40% of teams achieved autonomous navigation this year. We are witnessing breakthroughs across models, algorithms, design, and hardware integration. The specific phrase, breakthroughs across models, algorithms, design, and hardware integration, is not marketing language. It is a technical description of simultaneous improvement across every layer of the stack. A robot system that improves in hardware alone gets faster. A system that improves in hardware and algorithms simultaneously gets faster and smarter. A system that improves across hardware, algorithms, design, and hardware integration at the same time, with 100+ teams competing in parallel, generating diverse approaches to the same platform, that system is on a fundamentally different improvement trajectory than one where progress is sequential and gated by single points of bottleneck. What the April 19th race demonstrated, more than any single time or any single robot's performance, is that China's humanoid robotics ecosystem has passed the point where progress is gated by any single engineering constraint. The constraint is everywhere, and everywhere it is being attacked simultaneously by more teams, with more capital on a more standardized hardware substrate than at any previous point in the history of this technology. Here's the question I want to leave you with, because it is the one that the robotics research community is genuinely arguing about right now. The April 19th race demonstrated that China can build a humanoid robot that runs faster than any human in a controlled, prepared environment, with support crews trailing and a rehearsed course underfoot. Rodney Brooks calls that a publicity stunt. The Chinese teams running the race call it proof of engineering capability. Both descriptions are accurate for what they describe, and they describe different things. The question that actually matters going forward is whether the engineering improvements that enabled a 50-minute half marathon, liquid cooling, joint heat resistance, motion control algorithm depth, simulation training at scale, are the same improvements that close the gap to real-world unstructured environment performance, or whether that gap requires a completely different category of breakthrough that the half marathon tells you nothing useful about. If you work in robotics, in manufacturing, in logistics, or in any industry that has been told to expect humanoid robot deployment within the next 5 years, that is not an academic question. Drop your precise answer in the comments, because the people who know the answer are the ones closest to the hardware, and I read everyone.